Hello everybody, welcome back to the training of the Modicon M221. In this video we're going to continue seeing the power meter, and now what we're going to do is to read more data from the power meter, but we're going to focus only on the different data types that we have on the power meter and how we can read those variables on the power meter to easily see what does that mean and how we can use it in another system, for example, an HMI. So let's go to the presentation. This is our architecture, or how is the connection. We have already seen in the previous pass the configuration for the Modbus and how we can troubleshoot it. Now what we're going to do is to read this specific data, UTF-8, the integers, the different type of integer, the float, and the data time. So in the previous part, we already see how is the communication of the Modbus, okay, which is the pin out that you need for the cable that you have in order to connect with the power meter. These are some reference for what we've seen in the previous video. Now, what we're going to cover is these variables, how we can visualize this information. Okay, once you get the idea of one of those, the rest is going to be easy. So the challenge in here will be this one, the data time, that basically are 4 words. We need to read 4 words, one after the other, and then inside there are some bits, specific bits with some information, as you can see over here. Okay, so the main idea here, or what is going to take more time, is this one, date and time. So let's start with the UTF-8. Okay, if we go to the to here, okay, we can see that the UTF-8, we have meter name, model, and manufacturer, and some data, okay, that basically tells you some information in text. So the M221 doesn't have the possibility to see the text in that way. So in order to see what is in here, okay, let's go to the presentation, what is in here, okay, meter model, what I'm going to do is to use an HMI. I'm going to simulate an HMI to properly see this information. So this is the configuration that we need. We have already explained in the past how to add a channel. Okay, so let's do this. So if we go here, the meter model needs the register number 50. And as explained before, we need to subtract 1. Okay, so in order to read this information, the offset will be 49, okay, and the length with 20. And this is because on the size or here, okay, the words have 16 bits, so it should be 20, okay, 20 words. That's why they use the length 20, okay. So let's try to configure this on the PLC. Okay, just open the PLC. So we need to go to configuration, channel. Here in the channel, we just need to add a new one. Register 0050, configuration 49 and 20. Here, what we need to do is to read multiple words, and let me just double check here. Da, da, da. Want to use the same meter model. Okay, so this will be the meter model. Everything is fine. Cyclic. Okay, 49, 20. So if we want to read this information now, for example, let's just create another table. Add table, table, PM, UT, UTF-8. Okay, so here we need to add those variables, and if we go to input register, we can find all the 20 registers that we have already created. So let's start with this one, IWN 1.0. What zero? Let me just double check. EWN 100.1. 100.1.0, and you're going to specify to read 20 like this. Okay, and you have this information. So let's connect to the PLC and see the behavior. Just to show you, I'm directly connected with the power meter. Okay, I'm going to download this to the controller just to show you that I'm going to a physical device. Wait for this to finish. Okay. Okay, so I'm reading something, and as you can see over here, I'm able to understand what is in there. So probably the best would be to, for example, move these variables to a percentage NW so I can use it on the HMI and define a string variable so I can read this information properly. So if we go over here, okay, I'm going to disconnect from the controller and I'm going to add a new run. Okay, I'm going to move this information to a percentage NW. And the best way to do it is like this. Okay, we can define a percentage NW variable. Okay, define the amount of the words that you want to move from one side to the other. Okay, so if we go back to the application, it was the variable and 1000. So I want that all that data will be in the M1000 colon equal percentage IWN 100.1.0, okay, colon 20. So I'm going to move all this data to the percentage NW 1000. Okay, so I'm going to save this, going to connect with the PLC and download this. Okay. Okay, perfect. So now what I'm going to do is to open one of the software that I have, which is the EcoStruxure Operator Terminal Expert. I'm going to create a new project to simulate the HMI inside the laptop and connect to the PLC to see that data. So I'm going to select another HMI that I have here, the one I like. Here I'm going to specify the driver. The driver will be the PLC that I'm going to use, should be the M221, and I'm going to use the Modbus TCP with the PLC. So here the name of the driver or the equipment will be the PLC M221. The IP address will be the 192.1.221, which is the one I have configured on, okay, play over here. On this part. Okay, so now let's go back to the here. What we need to check here is this. Okay, addressing mode. I'm going to use this one. Here has the 0 or 1. Okay, it's going to be 0. And this one is to swap the order. I'm not going to change that. Okay, I'm going to leave it as it is. Now, what we're going to do is to create a variable. So here I'm going to create a string variable. Okay, this one will be M221 power meter 5XX, and I forget what I'm going to do. Meter model. So meter model. You can use a lower syntax like this. So the source will be the PLC, and the address will be the percentage 1000 that I already specified on the other side. Okay, now we need to specify the amount of characters. So in this case will be 40 bytes, okay, because I'm reading 20 words, okay. So this is it for this part. Now, in order to visualize this, I'm going to select variable string, okay, the object, okay, characters 40. I'm going to show less, don't worry. Okay, now what I'm going to do here is to select the variable I have created. Variables, power meter, one way, okay, because I'm not going to change anything. Disable input. There we go. So now we can simulate the device and we should be able to see the data from the power meter. If everything goes well, we should be able to see the reference, and we have here the reference. So what we have done here is to read the bytes for the alphanumeric data type that we have on the power meter, move the values of the percentage NWU of the IO scanner into percentage NWU values of the PLC, so I can read from an HMI and define that variable as a string, so I can really see what is the content inside that. So this is for the UTF-8, if I'm not wrong. Now let's continue with the next one. I'm going to close this. So, okay. Now, the next variable is the int 16u and int 32u. The u is for unsigned, okay? And in here you can see this one is the model of the power meter that I'm using, okay? And this is the serial number that is based in these two variables, okay? Manufacturer unit ID and the serial number. So I'm going to read these two variables. So on the PLC, what we need to do is to specify to read from this register and read 3 because this one takes 1 and this one 2. So let's go to the application. Going to disconnect from the controller. Remember that this one is just to show you how you can handle or how you can manage to read different data types. Here, what we need to do, let me just go back here into the presentation. Okay, channel 2. This one will be register 0129. Okay, and this one will be the manufacturer ID plus number. Serial number. Okay. Here I only want to read, so multiple register offset will be 128 and the length will be 3 words. Okay, as I explained you before, I'm going to read these two variables. The first one takes only 1 word and this one 2 words. That's why the length is 3. And I need to subtract 1, okay, for base 0, okay, that I explained before. Here I have already added the channel, okay, apply. Now let's create a new table over here. Add new table underscore power meter, and this one is the int variables. Okay, so here, if I'm not wrong, it start with 2, this one 0, and the other one this 2. Okay, good. If we go back here, okay, on the IO scanner status, no, input register. Okay, at the bottom it has the three new variables. Okay, the first one is only for one variable, and the third one is for only one variable. So we need to see how we can see that integer for 32 bits in only one variable. So let me go back to the presentation over here. Okay, so I can explain you one of the things that we need to be aware of. When we read from the power meter the size, not the size, but for this type of variable, what we need to be careful is that the swap. So what we need to do is to swap the variable, okay, the percentage NWU or the word that we had at the beginning to the other one, to swap it. Otherwise, we're going to see different information. That is one to show you right now. So in this example, okay, as you can see over here, I have made an animation table with this. So if I'm reading this information, okay, and if I want to use the percentage MD for the word, okay, this should be the number. If you can see over here, this doesn't match the serial number that I have. Okay, so what we need to do is to swap the lower and the higher position inside the double word in order to see the right information. Okay, so we have two ways of doing this. Okay, what we can do is to use or move directly the information that I want from here. Okay, you can see here I'm moving the high part to the lower and the lower part to the high part. Okay, so I can't easily assign which should be the part that I want to show. Another way is to move the two variables that I have directly into the two words that I have, okay, memory words, and then read the percentage MD for that specific place. Okay, remember that the percentage NW, MD, and MF share the same location. Okay, that's why I'm going to roll. So what it's going to do with the roll is different to the shift. The shift, if you have the word and you just move the 16 bits from one direction, it just complete the rest with zeros. In this one, what it does is to swap them. Okay, that's why you can use the roll in there. So let's try to use this in order to see the data. So the first one is only the manufacturer ND, and this one is the serial line. So let's try to do this on the other side so we can see this information. So let me open the Machine Expert Basic here. Good. So now what I'm going to do is to add a new run. I'm going to assign the manufacturer ID to the percentage NW 1102 percentage, no percentage, no, column equal percentage IW and 100 to 0, okay, which is the first one. Now I'm going to move I'm going to do something like this, okay, and then roll it. So I'm going to roll move the position here, the two positions, okay, to 102. And as I mentioned before, the percentage NWU uses the same position NW, MD, and MF. What I'm going to do now is to roll this. So MD 1110, roll that variable MD 1110. I'm going to roll this 16 bits. Okay, Going to save this. I'm going to log in the controller and download it. Okay, so we can see this information on the other side. And what we need to pay attention is that the difference between unsigned and not signed and unsigned variables. Otherwise, the last bit, the bit 16 or the 32 bit, is gonna be for the sign of the variable. So programming, okay. Okay, so now what we can do is to go to the EcoStruxure Operator Terminal Expert, Project, Variables. I'm going to add unsigned double int. Okay, this one should be PM5XX serial number. This one, if I'm not wrong, is the 1100. Let me just have a check. 1100. My bad over here. That's why I get it confused. Okay, you just already see that is similar to the one that I have on the presentation. So 1100, and if you go over here and the 1100, the other one for unsigned int should be manufacturer PM5XXX. Manufacturer ID should be PLC and offset. This one should be the percentage NW 1102. Okay, if I'm not wrong, yes, it should be like this. Let's double check with the application that we have. MW1102 and the other one's MD1100. So if we go now to the HMI, just drag over here the numeric, should be two numbers only, current value, variable, manufacturer ID, one way. There we go. Just going fast because I'm not going to explain this part, this for the how to work with the HMI, just to show you. Okay, and this one is the serial line. So this one, I don't know how many numbers do we need to show here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 numbers we need to show over here. 10 numbers. Okay. Zero suppress, no. Current value, serial number, one way. Disable input. Now if we simulate this, hopefully we see the same as the target. So if we go over here, send the presentation, oops, on the other side, and show this. Okay, you can see here that we are reading the serial number and manufacturer ID. Okay, so this is something that we need to check. Okay, once if we are reading only integer variable from 16 bits, there is no issue, as you can see for this part. Okay, but once you are reading 32 more, you will need to be careful, okay, about the swap. Otherwise, you're gonna receive a wrong information. You can see on the top here. If you don't do anything, I just want to share the information, you're gonna see anything else than what you want. So that is something that we need to be careful. And this apply also to the real variables, the float that we're gonna cover now. So if we go back to the presentation, let me just close this. Now what we're going to do is to read the nominal voltage, okay, which is a variable that we can configure on the power meter. So what we need to do is to add another channel and point to this direction. Okay, so let's go to the presentation, to the software here. Okay, so I'm going to disconnect. Yes. Configuration over here, channels, add channel, configuration. Here is going to be register 2018. This one is the nominal, oops, nominal voltage system. Okay, I'm going to read information with here's 2017. I have already explained this part, and this one is a float variable, 32 bits, and it's going to be 2 words. Okay, okay, apply. Programming, let's create a new one for the table underscore float is float, just forget, yes, float 32. Okay, and here, just forget this one, IW 103, percentage IWN 100.3.0.1. So these two variables will retain the float variable that I want, okay? And this one can be a little more complex because the structure for the percentage NW, percentage MD is different for a float variable. That's why we need to be careful with the position of the bits inside, otherwise you're gonna receive something else. So let's go to the presentation here, continue with this. So what I'm going to do now is to swap this, and let me see an example which variable I have used. Okay, so this is what I meant, to be careful. So if we don't swap this information and share the information directly in percentage %mf, you can see this one is totally different to the one that we should have, which is 230. Okay, and if we share the percentage MD, as you can see, is something else, and percentage MD is something else. Even if these two share the same uh, bit position, okay, how the system interprets the percentage MD and percentage MF is totally different. That's why we need to be careful. And if we want to share this float 32 variable, we just need to specify the percentage MF. Otherwise, we're going to have something else. So let's go and see if it should be the percentage NW 1200. So here, let's make a swap. Okay, let's continue with this. Here, percentage NW 1000, 10, percentage IW and 100.3.0. Yes. No, it's wrong. This one is the one, and this one is the one. Otherwise, there is no swap. So, okay, now I'm going to connect to the controller, PC download. Okay, play, and there we go. So, if you take a look here, if you want to read the percentage NW, it doesn't make sense. Okay, so for example, in the table percentage NW 1200 1 M MD1200, you can see nothing, but if we use the MF like this, the information is correct because the system interprets how the percentage MF or float variable should be represented. That's why if we read in a float variable, even if we receive float, even if we receive MWs, two MWs, we need to make the treatment to use the percentage MF in our system and then show that information on the HMI. And if we want to show this information on the HMI, variables, in this case should be real variable, PM5XX, voltage, real, external, this one, 1200, okay, screen, let's just add a new variable over here, float fix, 3 and 1, for example, variable, voltage, one way, okay, there we go, and now we should be able to see the 230.0. Put it on the other side, and there we go. So this is how you can treat the float variables that comes from the power meter, okay, into the PLC and then into the HMI. So now let's continue with the other part of the presentation. Just close this. Up. So now, where is it? This. I'm going to start with the date time. Probably this part is the more complex one because we need to work inside the information that we have. So let me just. So what we need to do, I'm going to read this variable that we have over here that contains the date and time where the last power failure. Okay. So what I'm going to do, okay, I'm going to add this variable over here, okay, and read 4 consecutive words. So let's go to the application in the PLC, going to disconnect, okay, just hold on a minute, there we go. Configuration over here, channels, going to add a new channel over here. This one should be the register 1829. You can use another name, this is just to know what is in there. And last power failure. Here, 1829, and I want to read 4 words and only modbus register. Okay, and apply. Good. Now, if we add animation table here, date time. Okay, I'm going to add IW4, yes, this one, IW100, IWN 104.0, going to be force. Okay, so now going to connect to the PLC with this new information. Download. Okay, good. Yep. Okay, play. So this is the information that I'm reading. As you can see, we are not able to identify what is in there. Okay, because if we go back to the presentation, okay, the information inside is located in bits, okay, and represent different stuff. So, for example, the daytime is divided in 4 words, okay. This first one will give you the year, okay. The second one is related to day and months, depend on the weekday, if 0 is not used. And the third one is related to the time, so minutes, hours, and then the daily saving or not, and the time synchronization quality. And the fourth one is for the milliseconds. This one is the easiest one. As you can see here, you just need to move this to a percentage NW variable, and then you can find the milliseconds. In here, it should be 27 seconds, okay, because it's in milliseconds. These two are the more complex because you need to identify inside the data that you have in bits what is the information that you have and what is what you want to show. So in this case, for example, the first word, okay, the bit 7 and bit 15, okay, these are reserved. So in theory, I really don't know what is inside. So probably it would be much better to delete this part and take all this. And for the rest of these two variables, probably the best is to use some function block to move from one side and then take only the information that we want. Okay, so if we continue with this example, okay, the idea is to use this logic. So let me just use the pen. Okay, good. So what we can do in our PLC, okay, is to use an auxiliary variable, for example, this one, which should be the last one um, that is an auxiliary variable, okay, that will have the percentage NW information from the PM, okay, PM, this move in this auxiliary, and then with this auxiliary we can execute two function blocks, two functions, SHL and SHR. So we shift everything to the left, X positions, and then we shift everything to the right, Y positions. Okay, that is the idea. So if you take a look over here, we only want to use this part. Okay, I really don't care what is in here. Okay, so what we can do is to move all this to the end, because when we move, if this is the word, okay, from 16 bits, I don't really care this about this part. And in this case, I'm lucky enough that I receive zeros, but the the truth is that I really don't know if it's this 0 or 1 and so point on the power meter. So I rather delete all this part. So in order to delete this part and only take only these bits that I want, the only 7 bits that I want, from bit 0, from bit 6, I need to move everything to the left, to the list, okay? So as you can see here, okay, I have moved all this to here. And when you move the bits to the left, the red bits are new data, okay, if this is new, and it's filled with zeros. Okay, so now I have all the bits that I know, okay, and the zeros, but this information is totally different to the one that I had at the beginning. So in order to easily read this information, I need to move all this into the beginning and complete all the information with zeros. In order to do that, we need to use the function SHR, okay? So in that way, I complete all, if you can see here, everything, all these variables that I really don't know if it's zero or not. Now I know that it's completed in zero, okay? And I move all the positions that I want, like this, okay? That is the idea, okay? How you can separate the bits inside the word, just to identify and be clearly identify what you want to show. That is one way. I didn't come up with something else to do it, but this is one way to do it. So let's continue with this. So if we, let me just
delete everything over here. Here you can see that we were able to uh, to to move and retrieve only the data that we have. Okay, so if we want to share this information to the HMI on read it or make something, we just need to use the percentage NWU that I have at the end. In this case, this one. Now, oops, let me just go back here and change this. Bam. Okay. Now we have already covered the first word one. Okay, to retrieve the year. Now let's talk about the second word to check the day and month. So this is a little bit more complex. Not for the day because it's at the beginning. So the idea is the same. As you can see over here in the right part, I use an auxiliary variable, okay, auxiliary variable to use in the same function block, okay, these two variables, these two functions SHL and SHR, okay, to move to one side and then retrieve. Okay, as you can see over here, what is the information that is going to be lost. Okay, even if this information has something, in this case, I don't need it. Okay, and then I have new information over here. From here to here, this is new, which is 0. And then on the next step, I'm going to move all this to this part. So all this would be new. Okay, that's basically new. That's basically the idea. Okay, and if you can see over here, if you want to read this part, this will be equal to this. And now after the elimination and everything, this is the value. Okay, this should be the day. And now it makes more sense. Day, try that everything that I have in there. Going to delete all. Now this is where the funds begins. In this case, the information that I want is not at the beginning or at the end, it's in the middle. So similar, we just need to move lowest position. But in this case, we also need to delete this. We can start to moving to the right, but then we need to add another one to the left and then another to the right. So because this information I don't know. That's why probably is to move, it's much better to move to the left to delete everything and then to the right. Okay, so we move to the left, this position that I need to move, and then I moved all the way around to the other side to complete everything with 0 in both ends. Okay, as you can see over here. So we can delete all the rubbish information that I don't want. As you can see here, I only retrieve the month that I want in this case for the word number 2. Okay. Now, for this one, which is the middle, which is for the weekday. Okay, as you can see over here, is in the middle. Okay, the value is 0, and it's the same process as this one. Instead of beginning from here, it began from here. Okay, for this, I need to move all the way around to the left and all the way around to the right. And you can see here the amount of position. I move 8, 1, 2, 3, 4, 5, 6, 7, 8 to the left, and then all the way around to the other side, which is this one. Okay, that is how you should work on this one to retrieve that information. Just explain you how to um, read proper the data that you have in there. And the last one for the minutes, okay, which is the word 3, okay, is the same process, auxiliary variable over here for the word 3 that I'm reading from the device, apply the SHL and then the SHR, depending on the size that you want, the different will be the number, okay, all the same, all of this. The same applies also for the time, for the hours, it's the same, this time is in the middle, this is how it works, okay. Move to the left and then move to the right, the amount of position indicated over here in order to retrieve the information that you want. So now is the big question, because This can take so much time and probably can cause some errors. Okay, it's not that it's so complicated, but probably too much time doing this, it can cause an error. And the best way to avoid having such an errors in the program is to use the function block. So we can have a function block where we can define all the logic that they have behind, okay, for all the different words that they have in order to easily replicate in case I need to read different or more than one data time variable. Okay, that is the idea of the function block. And I come up with this solution, for example, where you can, oops, you can create your own function block. Okay, and inside you can see here, okay, I have four parameters input, okay, datetime or 1, 2, 3, and 4, okay, that I use on the logic of my program. And then inside the function block, I analyze the complete data. And in the particular case of the year, I add the 2000, okay, just to see the proper year. So this is how you can work. You can analyze this is the same as we see before in each step, okay? But instead of using percentage NWUs or directly the IWM variable, I use the parameters that comes with the function block that I created. So if you want to use this in the configuration, okay, you just need to call the instance, the number of the instance, okay, and then the parameter that start with this 1, 2, 3, and 4, and assign the variables that come from the power meter. Okay, then how to use it and show it in another place, we just need to use the instance, the number of the instance, and then dot what we want to show. Okay, and this information comes on the function block. So now it's time to you to make your own um, function block, but I'm going to show you my application. So I'm not going to create all these steps over here because it's probably take so much time. We don't have it. So what I'm going to do is to open the application I already made, okay, which is in the other side. Okay, bear with me. So here I have the application. So I'm going to connect to the PLC and download it. I haven't changed my bad. Here, USB, login. Okay, download to the controller. Okay, good. Play, and there we go. So if we go to the logic here, I have already specified that information that I'm going to read, which is over here, the register. Now, if we go to the program that I was made before for this, you can see the date and time and how it's distributed, okay? You can see this the same logic, 21 this year, and you have today, probably a little bit confusing because it's today, it's the same day as the month, but trust me, it's the information. Here I have the date and time, okay, and this is how I reading the application, okay. If you go over here, user defined function blocks, you can see all the parameters that I have been used. These three for inputs and all these for outputs, so you can use that in your program. You can see here all the data, how it works. And if you go to how it's used, you can see over here how it works. So I have assigned the same IWU to receive the same data. You can see, for example, here on the top, IW 100.4.1.2.3, and it's the same data that is in the same function block that I had created. Okay, and then here you can see the final result. Okay, the day and everything. So probably I can make some tricks over here just to show you that it's different. Just remember maintenance setup. Okay, alarm clock. So we can edit this and we can specify the date. Let's add 12. Yes. Okay. So what I'm going to do now is to, oops, is to remove the power supply. Okay, so we have a failure. Okay, then we need to reset the IO scanner. Okay, okay, turn off, power on again. Here, let me see where I have it. IO scanner. Okay, reset IO scanner. Okay, I read information. Now you can see the day is 12. Ah, now you can see it. The day is 12. Okay, so this is how you can make your own function block. Of course, you can use this one if you want. Otherwise, you can use the manual entries. You can see it takes more time, and if you have an error, it's much difficult to understand where it is it. So this is how you can read different variables from the power meter, and depending on the type of variable, you have different procedure how you can read the variable, analyze it, and then show it on the HMI or not. It's up to you, but this is how you can um, read information from the power meter. I haven't specialized on which is the important information that you must need to use of the power meter. I don't cover that part because it's for me it's much better for you to understand how to read the data. That's something really specific. So thank you very much for watching this video, and I see you on the next one.